Hello friends, we start a class on real sequence. This is the third class. In previous two classes we discussed some definition and examples on real sequence and a representation of real sequences. In this class we discuss constant sequence and bounded sequence. Okay, so first we write the definition of constant sequence. Okay, let xn be a real sequence. Let xn be a real sequence such that xn equal to k for all n belongs to n. Okay, for every natural number xn equal to k, then the sequence xn is said to be a constant sequence. Okay, let xn be a real sequence such that xn equal to k for all n belongs to n, then xn is said to be a constant sequence. Okay, so that is, the sequence is xn, this is x1, x2, x3 and so on. Okay, k so on. Every term of the sequence is k. Okay, every term of the sequence is k. This type of sequences are called constant sequence. Note the range of a constant sequence is a singleton set. Okay, the range of a constant sequence is a singleton set because the range is only k. Okay, here now some examples of a constant sequence is xn equal to 5, that is 5, 5, 5 and so on. This is a constant sequence. Okay, number 2, xn to pi, this is a constant sequence. Okay, this is a constant sequence. Number 3, xn equal to the power n, this is not a constant sequence. 2 square, 2 cube, this is not a constant sequence. Constant sequence. Okay, this is not a constant sequence. Okay, so this is some examples of a constant sequence. Okay, now we will find bounded sequence. Okay, bounded sequence. Okay, let xn be a sequence in R. Okay, let xn be a sequence in R. Then number 1, if there exists m belongs to R such that xn less than equal to m for all n. Remember, this implies the sequence xn is bounded above. Okay, the sequence xn is bounded above. Okay? If there exists m belongs to R such that xn less than equal to n for all n belongs to n, this implies the sequence xn is bounded above. For example, the sequence minus n. Okay, the sequence minus n. This is the sequence minus 1, minus 2, minus 3 and so on. So for all n belongs to natural number, xn is less than or equal to minus 1. Okay, this is our m. Okay, clear. For every member is less than or equal to a fixed number, the existing belongs to R such that xn less than or equal to m for all n belongs to m. So if xn is a sequence this, that is minus 1, minus 2, minus 3 and so on, then for all n belongs to n, each xn is less than or equal to minus 1. We take minus 1 as n, then I say that this implies this sequence is bounded above. Yeah. Okay. So this is the definition when a sequence is called bounded above. Number 2, if there exists a small n belongs to R such that xn is greater than or equal to small n for all n belongs to natural numbers. Okay, then this implies the sequence xn is bounded below. Okay, then the sequence xn is bounded below. Okay, the sequence xn is called bounded below. Okay, for example, xn equal to n. Okay, xn equal to n, that is 1, 2, 3 and so on. So for all n belongs to natural number, each term of the sequence is greater than or equal to 1. Okay, we take this as n, small n. Okay, so this implies the sequence xn is bounded below. Okay, so for there exists small n belongs to us such that xn is greater than or equal to m for all n belongs to natural number, then we say that the sequence xn is bounded below. For example, this. Okay, this one is taken as n. Okay, now bounded sequence. Number 3, if there exists a small m and capital M belongs to R such that m less than or equal to xn less than or equal to capital M for all n belongs to R, for all n belongs to n, then the sequence is bounded. Okay, if there exists m and m belongs to R such that m less than or equal to xn less than or equal to capital M for all n belongs to n, this implies the sequence xn is bounded. For example, if we take xn equal to 1 by n, that is 1 half, 1 by 3, 1 by 4, 1 by 5 and so on. Okay, then for all n belongs to natural number, 0 less than xn less than or equal to 1 for, okay, so we take m equal to 0 and m equal to 1, then m less than xn less than or equal to capital M because less than or equal to means less than or equal to. Okay, less than or equal to, so any one condition can be held, either less than or equal to. So if m equal to 0, the condition is less than. Okay, if we use the less than equal to, then the condition is either less than or equal to. Okay, so this condition is true, This implies the sequence xn is bounded. This implies the sequence xn is bounded. Okay, clear? Now SW is some example which are bounded or not. Okay, check from this sequence says which are bounded or not. Okay, check for these sequences which are bounded or not. Okay, this is your SW. Now result a constant sequence is bounded. Okay, a constant sequence is bounded. Clear? Because a constant sequence is of the form, if xn, this is a constant sequence, then xn equal to k for all n belongs to n. Okay, where k is a constant. Okay, xn equal to k for all n belongs to n. So we take k less than equal to xn less than equal to k. Okay, or we take k minus 1 less than equal to xn less than equal to k plus 1 for all n belongs to n. Okay, so we take these as m and these as capital M, and then we say that xn is bounded. Okay, so a constant sequence is bounded. Okay, a constant sequence is bounded. Now unbounded sequence. Okay, unbounded sequence. Unbounded sequence. Okay, let xn be a real sequence. Okay, let xn be a real sequence. Then number 1, xn, if xn is not bounded above, then the sequence xn is said to be unbounded above. Unbounded above. Okay, then the sequence xn is said to be unbounded above. Okay, number 2, if the sequence xn is not bounded below, then the sequence xn is said to be unbounded below. Okay, a sequence which is not bounded above, is called unbounded above, and a sequence which is not bounded below is called unbounded below, and a sequence which is not bounded and if xn is not bounded, then the sequence xn is called unbounded. Okay, this is, if a sequence is not bounded, then it is called unbounded. For example, we see, for example, number 1, if we choose xn as L, this is a real sequence. It is 1, 2, 3, 4 and so on. This is not bounded above, so therefore x enter unbounded above. Okay, unbounded above. Okay, this is not bounded above, so this is unbounded above. Okay, number 2, if xn is as minus n, that is minus 1, minus 2, minus 3, minus 4 and so on. Okay, so this is not bounded below. Okay, this is not bounded below, therefore sequence is unbounded below. Unbounded below. Okay, and if the sequence xn is taken as minus 1 whole to the power n into n, okay, then it is minus 1, 2, minus 3, 4, minus 5, 6, minus 7, 8 and so on. So in positive side 2, 4, 6, 8 and so on, and in negative side minus 1, minus 3, minus 7 and so on. So not bounded above as well as not bounded below. Okay, not bounded above as well as not bounded below. That is not bounded. Okay, that is not bounded. Therefore xn is unbounded. Therefore xn is unbounded. Okay, so this is some definition of unbounded sequences. Okay, that's it. Another definition of bounded sequence. Another definition of bounded sequence. Xn be a sequence in R. Xn be a sequence in R. Then xn is bounded if and only if there exists m greater than 0 such that mod of xn is less than or equal to m for all n belongs to natural number. Okay, for all n belongs to natural number. This is another definition of a bounded sequence. Okay, for example, if we take xn equal to minus 1 whole to the power n. Okay, is this sequence. This is a sequence which is 1, minus 1, 1, minus 1, 1, minus 1, 1 and so on. Okay, then mod of xn is equal to mod of minus 1 whole to the power n and is equal to 1. This is less than or equal to 1. This equal this taken as n which is greater than 0. Okay, so this is a bounded sequence. This is a bounded sequence. Okay, similarly, if we take this sequence xn such that xn equal to sine n pi, this sequence. Okay, so this is the sequence sine pi 0, sine 2 pi 0, sine 3 pi. Then mod of xn equal to mod of sine n pi. Okay, this equal to 0 for all n. With this less than equal to m if we take m equal to 1, is less than equal to 1 is taken as m, okay, which is greater than 0. So this is bounded. So this is a bounded. So this is a bounded sequence. Yeah. Similarly, this is HW. Check xn equal to sin n pi by 2 is bounded. This is HW, okay. Sin n pi by 2, this is also a bounded sequence, okay.